Welcome to Solving Systems of Equations with Matrices. Today we're going to write an equation in matrix form and a system of equations, and we're going to solve any size systems of equations. I mean, we're going to be able to solve a 10 by 10 system in the amount of time it takes you to type all the variables, the constants into your calculator. Before we get to that, let's just take a second and kind of solve these two systems of equations using matrices. So the first thing we're going to have to do is set up our matrix equations, and we're going to have three matrices that are part of this equation. The first one will be our coefficient matrix. So we're going to have a coefficient matrix. We're going to have a variable matrix. And we're going to have a solution matrix. And so what I'll do is I'll have my coefficient matrix multiplied by my variable matrix is equal to the solution matrix. And that's essentially what you have here. Coefficient times variable minus coefficient times variable equals solution. So we're just going to condense that into a matrix form. So to create our coefficient matrix, C, we're going to take whatever the coefficients are of our variables. So 1, 2, -2, and -3. And we're just going to create a 2 by 2 matrix out of those. 1, 2, -2, -3. Now we know this is a 2 by 2 matrix, and I want to multiply that by my variable matrix. But in order to do that, it has to have 2 rows. So my variable matrix is going to end up being a 2 by 1 matrix. So we have our variables are just x and y, and we list them. So when you look at your equations, so if I look at this equation here, the variable I see first is x in that equation, and I see x first in the second equation as well. That's why x is the first part of our variable matrix. And then our solution matrix is written just like it looks. That's our 2 by 1 matrix. So what I have here is this system of equations that I've now written in matrix form, but now the goal is to solve this. So how do I solve it? Well, I have to get the variable matrix by itself, and to do that, I have to multiply both sides by the inverse of my constant matrix, or my coefficient matrix. So what that'll look like is this. I'm going to multiply, I'm going to write it out first. I'm going to multiply the inverse of C on both sides. So I'll have the inverse of C times V equals, and then the inverse of C times S. All right, so now let's see what that looks like in matrix form. So the inverse of C, now I can use my calculator to find the inverse of C, and I would highly recommend that. Just for ease sake in our video here, because we're going to use our calculators in just a minute, I'm going to go ahead and write that as, oops, I reversed that there. I guess we could find the inverse of this pretty quickly. We switch A and D, so this becomes -3 and 1. And we change the signs on B and C. And then we do 1 over A times D, which is -3. I'm going to write that up here. 1 over -3 minus -4, which ends up just being 1 over 1. So that's nice. Our little multiplier out in front is just 1. All right, so then let's write the rest of our matrix here. So we're going to write our original matrix C, which is 1, 2, -2, -3, times x, y, our variable matrix. Now that's equal to, again, we multiply both sides by our inverse. So our inverse was this, times 0, 3. Okay. Now, when I go through that whole process, I know that these two are going to be my identity matrix, which is essentially like multiplying by 1. Okay, so if you remember, our identity matrix is just 1, 0, 0, 1 times x, y. And remember, that's just like 1, and we'll come back to that in just a second. On the right side, though, we have to multiply out that set of matrices. Now, you can do this by hand, or you can do it using our multiplication process. Let's see, I take this times the column, so -3 times 0 is 0. Plus 2 times 3 is 6, and then -2 times 0 is 0, plus 1 times 3 is 3, and we get 6, 3. Well, that's really nice, right? Because we get this 2 by 1 matrix, which matches our variable matrix. So in the end, what we know, since this matrix right here is like multiplying by 1, what I really end up with is just xy equals 6, 3. So now I know x equals 6 and y equals 3. So this is the process for solving our systems with matrices. Now I'd like you to pause the video and try B and see if you can come up with the correct solution. Okay, so this is what we end up with. We should get x equals 4 and y equals 2. Here's the thing. I did this with my calculator as far as finding the inverse and doing this multiplication, and I would encourage you to do that. So if you did get stuck in this process, pause now and try and see if you can find it by just using your calculator to help you find the inverse and to help you actually do the multiplication. So let's just really quickly set this up so that we can actually find the solution without having to do a whole lot of work by hand. And I want to do that with the second one since we didn't really spend time on that one. What I'm going to do is I'm going to set up three things. I'm going to set up my coefficient matrix, and I'm going to set up my variable matrix, and I'm going to set up my solution matrix. All right, so here's what I know. I'm going to take my coefficient matrix times my variable matrix to get my solution matrix. My process to solve was to do the inverse on both sides. So the inverse times the right side and the left side gave me essentially what we call the identity matrix times my variable matrix, which actually, guys, just ended up being what? The variable matrix is equal to our solutions to the system, okay? So how we find our solutions is we just take the inverse of the coefficient matrix times our solution matrix. And I'm using the word solution there. You could use something different if you wanted to, but that's basic setup, okay? So what I'm gonna do is I'm gonna identify my variable matrix. I'm gonna write that down. In this case, that's x and y, equals, so the inverse of my coefficient matrix. So I'm going to write my coefficient matrix, 7, negative 10, negative 16, 8. And I'm just going to make this little notation here, the inverse of that, times solution matrix, which is negative 4, negative 24. This is what you're going to have to put into your calculator. So you enter our first matrix in as matrix A, second matrix as matrix B, and then you're just going to do the inverse of A times B, and that's how I got the solutions that you saw up above, which were 4, 2. So this process, if you can remember it, and we're going to go through this a couple more times, can make solving the largest system a piece of cake. So let's go ahead and try one. So we'll start kind of easy here, okay? We're going to start with this. It's really a 3 by 3 system because there's 3 variables and 3 equations. Now, what I would recommend is that you make sure that all of your equations are written with the same 3 variables in all 3. So if you're missing a variable, you're going to want to rewrite it, like this one, as 4x minus y plus 0z equals negative 5. And then I'll do the same thing here. 2x, I'm just going to rewrite my 3 equations. And then negative 2x plus 2y minus 3z equals 19. So my setup is this. I have my variable matrix equal to the inverse of my constant or coefficient matrix times what I'm calling my solutions, because that's what's on the right side by itself. So my variable matrix this time just has 3 variables, so x, y, z equals. Now I'm going to write my coefficient matrix. I keep wanting to say constant matrix. I'm going to do this by rows, so it just means I go straight across each of the equations. So I'm going to have 2, negative 4, positive 5. I'm going to have 4, this is negative 1, 0. And then I'm going to have negative 2, 2, negative 3. I need to do the inverse of that times my 3 numbers on the right side of the equation. So negative 33, negative 5, and 19. Now all that's left to do is put that information into your graphing calculator or into the matrix calculators that we've looked at online and multiply them together. So I'm going to have you pause the video and try that here. All right, did you get negative 1/2, 3, and -4. Hopefully you did. If you didn't, just go back and check to make sure that you didn't mistype something in your graphing calculator. All right, so this one looks a little strange because my variables are written kind of funny. It's x1, x2, x3. That's fine. It's really the same thing as x, y, and z. We're just using subscripts instead of different variables. So let's go ahead and rewrite these so that we have all of our variables present in the 4 equations, because this is now a 4x4. So I would write this as 10x1 minus x2, that's really like 1 there, plus 2x3. Now I do not have an x4, so I'm putting plus 0x4 equals 6. All right, and I'm just going to rewrite the rest of these doing that same thing. Go ahead and try that yourself. Now, in the past, a lot of my students have skipped this step, and I think it's a really important step because it lines everything up for you, and it makes sure that you have your matrices written correctly. If you don't have your matrices written correctly, you're not going to get the right answer. So now we write our matrices. So we're going to have our variable matrix equals the inverse of the coefficient matrix times our solution matrix. So this time our variable matrix has 4 variables. So we have x1, x2, x3, and x4 equals, our coefficient matrix is rather large here. I'm just, again, going to go straight across each of the 4 equations. So I'll have 10, -1, 2, 0, -1, 11, -1, 3, 2, -1, 10, -1, and then 0, -3, -1, and 8 times, and then 6, 25, -11, and 15. Now the good news is, again, we have our calculators to do all the heavy lifting here. So I'd like you to pause and make sure that you get an answer, and then come back and check to see if it's correct. All right, hopefully you got x1 is 1, x2 is 2, x3 is -1, and x4 is 1. And I'll be honest with you, when I typed this in the first time, and I even wrote it wrong, I wrote this as -3, and hopefully you caught that. It's actually +3. And when I typed in my original multiplication, I got some really strange looking numbers, and so I thought, well, I'll just double check that I typed everything in the right way. So I double checked, and I noticed that this was +3, and I had written -3. So I just did that double check, and I found my mistake, and then I was able to go from there. Okay, last one. Now I'm going to actually have you give me the answer to this one on your homework. This will be one of the problems that you have to write an answer for in your homework assignment. So I want you to try to set this up, and then once you've got it all done, you'll be able to enter your answer in your homework and see if you're right. All right, guys, have a great day. I'll see you in class.